All right, let's get into the meat of the panel here.
So the students get a better understanding of what construction technology is and then how to implement that in the future wherever they go.
UAV-based photogrammetry and UAV-based LiDAR.
This is a plastic solar cell. It catches light into electricity and you can roll it up and put it in your pocket.
We can basically take that image and create a digital twin of your knee or your shoulder or your hip.
In the virtual environment, when they get to the physical environment, they will be pre-trained, they will feel more comfortable.
Honestly, this is just the beginning of some very, very exciting times. A whole series of industries which are going to be very, very important as the years roll on.
Good afternoon, everyone, and welcome to the Digital Twins at Boise State. I'm Krishna Pakala, Associate Professor and Associate Chair in the Mechanical and Biomedical Engineering. I'm so glad to see you all. I heard many of you are from out of state, out of the country. I hope you loved the green belt and the Boise River that hugs the campus. And if you happen to go to the zoo, that's amazing too. So this panel that we have will take all of us on a journey, including me, from very small to very large scale, and you'll see why. We'll begin with molecular simulations at the atomic scale, move through biomedical systems and rock mechanics, and finish with some visualization and AR, VR, and the built environment. Along the way, we'll see how Boise State faculty, who are right here, are applying digital twins to advance teaching, research, and industry partnerships. As you all know, a digital twin is a virtual model of a physical system, and at Boise State, we are using them in plenty of powerful ways. From the nanoscale to entire buildings and cities, digital twins are preparing our students, who I believe most of you met, are not only using these tools to build, but to innovate with them in a global workforce. To set the stage, we will see a short video in a second, where you'll see the power of these digital twins in action, drawn from the work from our panelists. You will see Dr. Nick Hudyma's research group using UAV-based LiDAR and photogrammetry to produce digital twins of natural and constructed rock slopes. Whereas these digital twins are used as inputs to design software, where they perform simulation to understand stability issues and design remediation measures in a digital environment. The video will also show simulated rockfall at an unstable slope in Boise. Next, Dr. Fitzpatrick's team applies machine learning models to generate digital twins of a patient's anatomy, like the knee, which has been acting up for me. Claire, I need to get it checked through a model at some point. These models can include detailed subject-specific anatomy and material properties. We can convert these models to computational simulations to understand the way an individual joint will move, how it is loaded, and predict how it will be affected by injury or response to a surgery. Finally, we're excited to also feature a chemistry trainer video from Dr. Stephen Cutchins' group. This segment will show students performing virtual experiments in a virtual reality digital twin of a real-world college chemistry laboratory. They'll perform real-world experiments with accurate models of laboratory equipment in a lab that is same as the physical lab. The skills they practice in this virtual environment are transferable to the real world, hopefully. And then at the end of the experiment, we show the students everywhere they touched with their gloves and that have chemicals on them. From this, students get a strong understanding of the importance of glove hygiene in a lab setting. All right, AV team, let's play the video. All right, let's get into the meat of the panel here that you all came for. We're going to start small scale and we all go to the built environment. First, I'd like to introduce Dr. Eric Jankowski, who is the director of the Micron School of Materials Science and Engineering. He leads the Computational Materials Engineering Lab, where he and his students build molecular simulation and develop high-performance computational training, and that makes these powerful models possible. Dr. Jankowski, could you share more about how you use digital twins in your work in about 2 minutes?
Sure. Thanks, Krishna. And thanks, everybody, for showing up this afternoon. So my name is Eric Jankowski, and I run the Computational Materials Engineering Lab. And we try to engineer the nanostructure of different materials. So we work on things like organic solar cells. This is a plastic solar cell. It catches light, turns it into electricity, and you can roll it up and put it in your pocket. But it only works because the polymers that this is made out of are structured exactly right. You can take something that was normally an insulator, and if you get it layered in the right ways, you can use it to catch light and turn it into electricity. So we try to make next generation materials like this with our computer simulations, which are simulations of atoms and molecules at the tiniest length scales. And so our students learn computational literacies like Python programming, high performance computing, statistical mechanics, and we apply them to answer the question, given a collection of ingredients and processing protocols, what are the structures that will emerge through free energy minimization? And we use those answers to engineer better processing techniques and better compositions of materials to make these next generation devices with. The wings on a Boeing 787 aircraft, those are plastic, really similar plastic to these, and they don't fall off because of our simulations. The doors, that is mechanical engineering, that is not us. You have to talk to Claire and Krishna about that. Thanks.
Thank you, Eric. Now we'll go to Dr. Clare Fitzpatrick, who is an associate professor of mechanical and biomedical engineering and the director of the Computational Biosciences Lab. Her team creates digital twins of the human body, advancing biomedical research and opening new possibilities for health innovation. Dr. Fitzpatrick, over to you.
Yeah, so I'm Clare Fitzpatrick. In my lab, we use a lot of medical images. So if anyone has ever had a CT or an MRI, we can basically take that image and create a digital twin of your knee or your shoulder or your hip. And so we do that to try and understand, well, what's going to be the best treatment for you? You know, if you're going in for surgery, where should your surgeon put your implants? What kind of device should they use? We use it to understand mechanisms of injury. Why do some people tear their ACL and other people don't? So it's really very much personalized medicine. How do we take the variability that you see across the population, right? Every one of us has different anatomy. The geometries of our knees, of our hips will all look different. So how do we take that variability and actually harness it? So create a model of your knee and use it to help us understand what's the best treatment for you, or what's the best maybe rehab exercises you could do to stop getting injured in the first place, ideally.
Cool. You're all awesome. You're all doing great on time. It's amazing. Okay, for many of you, maybe it is your first time in Morrison Center or not. There's another person on this panel. It's first time ever. And Nick has been on this campus for several years, and I was happy to show him around, and welcome to Morrison Center, Nick. Dr. Nick Hudyma is a professor of civil engineering. His specialty is rock mechanics, and he develops digital twins of rocks to study how they fracture and fail, research with direct implications in geoscience, mining, and construction. Dr. Hudyma, please tell us more.
Excellent. Thank you, Krishna. Thank you, everyone, for staying for the last session. I really appreciate that. So in my research group, we're really answering this question, are the slopes unstable? And if they are, where is that rock going to move down slope? And so what we do in my lab, as you saw in the video, we use a lot of UAV-based photogrammetry and UAV-based LiDAR, and we scan cliff sides. And we take that information and we bring it into engineering design software, where we can look at which parts of the slope are unstable, which parts of the slope are stable, and we can try and implement remediation techniques. So if we notice that a rock block is unstable, we can put in virtual reinforcements to see if that will enhance the stability. On the video that you saw, it was actually a simulation of a basalt cliff in southeast Boise, about 5 miles from where I live. And what we did with that is we developed our digital twin and then performed the simulation of the rockfall event of rocks coming out of the cliff and tumbling down slope. And we used that information to try and design protection measures for houses, for roadways, for any infrastructure that may be impacted.
Awesome. Thank you. All right. So we might be able to create digital twins for a lot of things, but for this next panelist, I don't think there is another digital twin we can make of you, Anthony. He's amazing. So Dr. Anthony Ellertson is the Director of Games, Interactive Media, and Mobile Technology, the GIM program. And I'm sure you have visited their students and amazing work that they're doing. He works with students to create AR and VR applications that solve real-world problems with new work in AI integration and LiDAR capture. Dr. Ellertson, please share your perspective.
Oh, thank you. Yeah, this has been an excellent conference. Very exciting for me, for my colleagues, for my students, because we could see so many kind of synergies with the things that we've been doing or are interested in doing. So this is GIM's 11th year, and we started off doing actually medical simulations with custom haptics. And then we moved kind of quickly. Within about a year from that, we started to use structure sensors, and we worked with Idaho museum systems to basically scan artifacts that are just they're stored. They're too delicate to actually remove out. We were scanning them. We're putting them into a kind of an interactive space that would then let the public enjoy them, right? And I think that's kind of where GIM sits. Is we're the extended reality folks that basically take all these data points and create these kind of usability experiences that then can help the user better understand everything that's happening. We've also had a chance to work with LiDAR and drones with Dr. Megan Katao. Actually, we did augmented reality overlays of the terrain and lots of other projects beyond that too. But really, I think what we have seen for a number of years, what again makes us excited about being here is that honestly, this is just the beginning of some very, very exciting times as it pertains to spatial computing, as it pertains to extended reality and a whole series of industries which are just at the beginning, but which are going to be very, very important as the years roll on.
Thank you, Anthony. All right, next we have Dr. Stephen Cutchins. He's an Associate Professor of Computer Science. He specializes in visualization and was instrumental in creating the Stein Luminary, which you should check out if you have some time today or tomorrow, which basically connects the technology, the art, and the industry through immersive digital experiences. Dr. Cutchins, the floor is yours.
So if you have an opportunity to go see the Luminary, I highly recommend it. It's a large collaborative immersive theater where you can go in, and it has 3 large-scale active touch walls. The whole walls are alive. You can explore art, engage in arts, and groups of people can collaboratively explore high-resolution, high-quality fine art. So check it out. It's in the new School of Arts building. It's awesome. But in my laboratory and the video that you saw, the clips from, what we do is many students who come to college often don't have experience within different environments before they get to college. Often there will be students who go to college who have to take chemistry classes. This is true for construction, all kinds of different fields. They don't have this opportunity. So what we do is we're trying to use virtual digital twins of various work environments that are real world matches for the real world places that we've captured and recreated. And then using skills-based training within those virtual environments, we can take students through very close to the actual experiments. As you saw within a chemistry environment, they can repeat the same experiments that they will have to do once they get to the chemistry laboratory. And with the expectation that if we match the tools as much as possible that they're using in the virtual environment, when they get to the physical environment, they will be pre-trained, they will feel more comfortable, they'll actually know already where all the glassware is in the laboratory. So if you tell them to go get something on their first day, you don't have to show them. They already know where it is because they've already done it inside of the virtual environment before they get there. And this is a joint project. Boise State is the lead institution on it, but we're actually having about 200 undergraduate chemistry students at the University of Southern California engaged in doing this experimentation. And so far, the results from those students are that it has helped them to be more comfortable, less anxious, and more aware of where everything is in the laboratory that they're doing the simulation of. And our goal in our work is how can we better integrate realistic digital twins to enhance the skills-based training. And as you saw in this video, we can do in these virtual environments things we can't do in the real world, which is in this case, show the students all the places they touched that they shouldn't have when their gloves had chemicals on them. You'd be surprised how many students wearing gloves are answering their phones and drinking their coffee when they're not supposed to be. When we show them the tables all covered with little red blotches where they've left toxic chemicals, it's quite an eye-opening exercise for most of the students who are engaged in it. Thank you.
Thank you. Alex Hanna is an adjunct professor of construction management. He applies laser scanning and digital twin technology to the built environment, including Boise State's own construction projects like the new construction management building. Alex, please share more.
Yeah, I'm happy to be up here with you guys. I appreciate you guys inviting me up here to do this with you. BSU, the construction management department, in the BIM class, we are introducing technologies like laser scanning construction technology to further the class and understanding as these kids graduate and go out into the field. Currently, right now, there's a new CM building being built on campus. And as I am partnering with local contractors using laser scanners, terrestrials, drones, and SLAM scanners, right now we're collecting a bunch of laser scans and point data to hopefully integrate into the department and then build these digital twins so the students get a better understanding of what construction technology is and then how to implement that in the future wherever they go.
Awesome. As you can see, it's from really small scale to build, but they're really tackling real world problems and involving students along the way. So thank you all for sharing your work. Maybe it's time to move into a little conversation so that they can learn more from us all. So first question focuses around teaching, research, and industry. You can take any angle you feel like. And the first question is, how are digital twins changing the way you teach or conduct research? And how is this work preparing students to meet the needs of the industry? Maybe I'll start with Claire with a biomedical perspective.
Yeah, so I think traditionally, when people are designing new devices that are going to go into your body, they have very small subsets of data. So it might be just data from a handful of patients, and they're using that subset of data to extrapolate out to an entire population. And so that's obviously pretty limiting, right? Typically, you have a device that works pretty well for a very, the average person. But no one is the average person, right? We're all different. So instead, we can, with this digital twin approach, we're developing individualized patient-specific models for. We can actually start to look at, well, what's really happening across the population. We can take these scans from. We've done studies that have involved thousands of different patients, and built a library that describes how across this 1,000-person population, how their joints move and how the loads during their joint when they perform different activities, like going up and down stairs, getting out of car, all these kind of activities of daily living. And so we can start to understand what's happening across a population as well as what's happening at a particular individual level. And I think our students get an awful lot out of this research because it's so interdisciplinary. For not my lab, we need some mechanical engineering background and skills, coding skills, so programming in Python and C++ and MATLAB. And then you also need to know, need some medical biology background. And so it's enormously interdisciplinary. And so you have to figure out how to work with other folks. So other engineers, with biologists, with kinesiologists. And I think the world is becoming increasingly less siloed. For whatever your career is, you're probably not just going to be dealing with a group of mechanical engineers or a group of construction management folks. So being able to have those conversations and learn the language of other disciplines is, I think, enormously useful, whatever your application is.
Thank you, Claire. Let's switch gears, go to Anthony. Anthony, what are your perspectives of AR and VR in teaching, industry, research?
I'd say the sky's the limit. We're, again, just as I was describing some of our projects, we just continually find more and more uses where these technologies are kind of, touching on whether it's cultural things. I guess another project I didn't talk about, but we worked with augmented reality for the Anne Frank Memorial and the Wassmuth Center, and that's for preserving cultural heritage to, again, these scientific problems and engineering problems that we have to solve. I think right now the challenge for us is it changes very quickly. We have to be inside of our curriculum. We have to think a lot about not only software platforms, which are changing, but also hardware platforms that we have to be aware of, that we have to kind of test. And so in GIM, for example, we are constantly ordering, we get a piece of hardware in. We don't know if it's good entirely or not. Obviously we order things that we think are going to work well, but there's a lot of testing. We pull it in, we kind of look at it, we sort of see how it works out, and then we try to generalize that once it's done. And I'd say that's the challenge, or one of the challenges of this kind of curriculum right now.
Awesome. Thank you, Anthony. Eric, let's go some computational here. What are your perspectives on simulation and computing, and how does that you see in teaching and research?
Well, I think it's essential. Using computers to gain insight into something that would be otherwise expensive, dangerous, or impossible to probe otherwise gives you powers that the people that aren't doing that don't have, right? So engineering today, without taking advantage of computational tools, would be like trying to do science without calculus 100 years ago. You just can't do it. You're not operating at the same level as your competitors. So it's essential.
Awesome. I'll open it up for other panelists if you have a thought on this.
Sure, I'll go ahead. For me and my students, the use of digital twins is awesome. Right? If we think about how we had to do this back in my day, we would go to a rock slope face and we'd take hand measurements, but we could only take so many hand measurements, right? We couldn't, run up the slope because it was dangerous, and we could only, well, I'm tall, I could reach pretty high, but some of my students aren't as tall, so we were limited with the measurements that we could take. But using digital twins and using high-resolution digital twins means we can collect more data at our field sites. And then when we take that data into our engineering software, now we can start performing probabilistic analyses rather than deterministic. And we know the world is moving into probabilistic design, probabilistic analysis. So this has been a real eye-opener for us and how we can do this and how we can make our civil infrastructure more resilient and much more safer for the public.
Thank you. Steve?
I just wanted to say that, so as people attending the conference probably saw, digital twins is only getting bigger. Actually, there was a company outside that was advertising, I believe, creating a digital twin goal of the globe, effectively. And the pace with which digital twinning executing the data that's being captured, the 3D models the rock faces that are being collected is only increasing more and more and more, which also means it's going to be utilized and required to be utilized more and more within an educational environment, which I really think comes back to Claire's point, which I felt was really astute, which is that the interdisciplinary nature of both the education aspect and all the work. Our goal in education is to use these things to train students comfortably in environments that they will go work in, that they don't have access to immediately. But with the digital twin version, we can give them all the access to it and have those new skills and knowledge translate into the real world. But the challenge in all of that is it's a phenomenal amount of knowledge. It's a phenomenal amount of data. And it's a real challenge for students and educators and everybody involved to connect the different groups and the different knowledge together. But it's also going to be essential as digital twins play a larger and larger role in the educational environment. So I just finished with saying that I think understanding and looking at the essential interdisciplinary nature of utilizing digital twins and integrating them is going to become more and more important. And I just found that to be a really excellent point.
Thank you, Stephen. Alex?
Yeah, I was going to add on to Eric. What you were saying is technology is essential. And I mean, in construction, we can all agree here that that's pretty much mandatory now. We're even submitting 3D models, whole models of buildings for, completed set drawings and state stamps. But some of the challenges is there's so much technology now. What is that we teach, right? What do we show our students that they're going to take with them and know how to use? And so we got to kind of do a blanket generalization of LiDAR scanning, but they might have a Leica or a Trimble or a drone, and so I just wanted to mention there's some challenges with technology and introducing that stuff.
Awesome. So as you can see, our faculty are equipping our students with these digital twins and technologies, but then Anthony also mentioned sometimes it is a challenge to keep pace with it, so maybe we should take a little bit of future outlook. So the next question is around that. So looking ahead, where do you see digital twins having the greatest impact in your field and potentially globally over the next 5 to 10 years? Maybe Nick, I'll start with you.
Sure. I think for all of us, it's probably the connection between digital twins and the Internet of Things, right? When I think about digital twins, I think about the collection of data and the integration of data. And as a geotechnical engineer, I would love to have sensors all over every slope in Idaho. Right, so I could collect that data, and I can pair that with the digital twins and the upgrading of digital twins, and then of course the next step after that is, well, we can't analyze all that data. What are we going to do with it? And so I think now we're getting into machine learning, artificial intelligence, and running data through those sorts of engines to see how we can make sense of things. I think for me, that is in my field, I think that's the next really big step for us. And we're not there yet.
Awesome. Thank you, Nick. As you all saw, Boise is booming in construction. So Alex, what are your perspectives on where we are headed in your field?
The whole conference about digital twins. In construction, digital twins are, it's a dangerous word, I guess. I think yesterday's panel said it best. There's no standardization of what digital twin means to certain people. Mm-hmm. But Internet of Things, IoT sensors and stuff like that throughout facility maintenance management, stuff like that. I think they will play a critical role in the future. And we're getting to a point where it's more commonplace to hear those terms. How we teach that, still to be discovered.
Cool. Stephen, I'd like to hear your perspective on the visualization work you do, and what do you see is
where it's
yeah.
Well, I mean, as I think that it's pretty clear. If I had to summarize kind of everything that's going on here, and I think Anthony raised a key point as well, is that it kind of comes back to pace. the twinning is picking up, the computation demand is picking up, the compute resources needed is picking up, even AI development, which is going to play a larger and larger role in the integration, is picking up. This presents a real challenge. And the opportunity is to teach the students on these systems where we have to do this integration. So, and if they can try to keep up, and if we don't find ways to keep them integrated and educated and maintaining this connection, you'll see a divide between universities that succeed at it and universities that really struggle with it. So that's kind of one of the challenges inside of the place, because it does seem to be really getting faster and bigger and more of it. And how do we integrate AI? And within my lab, the big goal is, okay, as we do this, we want to make certain that we train the students on the necessary tools that they can do this integration and know what to do for the next step in the integration, and also demonstrate. Again, it's a challenge just to pick, okay, what skills can transfer from the virtual environment to the real world environment? What should we focus on, and what should we train them on? And when as Anthony pointed out, when the platform underneath you is changing so rapidly, there's a real challenge within education systems to integrate these tools and these platforms into these environments in a way that you can have the best effect on curriculum and getting students through and having them ready to go out and utilize these tools. So what's coming for us? More work, more challenges in figuring out how to do that. And that's really what's going on, and
Awesome.
how I see what's going on.
Awesome. Claire, Eric, or Anthony, do you have anything you'd like to add?
I think on the healthcare side, there's a move in some areas, at least, more towards personalized medicine. And so these kinds of digital twins, especially when you couple them with machine learning types of tools, allow us to bring some of the decision making into the operating room, so that the surgeon can either collect data preoperatively or intraoperatively and actually use that to inform what they're going to do for this particular person, not for a generic patient.
Yeah.
Awesome. Anthony?
I think I'd play off of some things that Steve was saying. Because of how rapidly things are changing, you have to help the students develop, I think, a different mindset, which is a little less bound with particular disciplines or particular kind of canonical areas of knowledge. I think they have to be trained, or they have to understand. They have to have a base, I should say, in things that they feel comfortable with. But then they also have to have this. They have to be comfortable with being uncomfortable, right? They have to have this reach where they're, hey, this new piece of equipment just came out. It's going to really change how you think about your practice. Don't resist it. Jump in, and just start playing with it, even if you don't do well with it, or even if you fail to begin with, to really get to the things that you want. That's not a failure, right? That's just you learning, and I think that's part of what we're facing as far as challenge to get that across, to do this thing in an interdisciplinary way.
Awesome. They've been an amazing crowd. We should surprise them with some more questions that I didn't tell you I'm going to ask you, but these are fun. So these are going to be quick fire bonus questions that I've planned here, but this will be fun. So if anybody can jump in here, let's talk about some student success stories. So can you share a specific example of a student project or success story that shows the impact of working with digital twins?
Oh, I have one.
All right.
We had an undergraduate student named Hannah Sparrow who came from Earth Science.
Yep.
Had done nothing with VR or digital twins, but she had this. She was working with a professor in the math department to do a little bit of simulation modeling on the I think it's the Teton Dam that failed in the 70s, I believe, and they were simulating and modeling, trying to understand what had happened. But she came and met with us, and in conjunction with two other students, another undergraduate named Kenny Miller, who now works for Idaho Power, who was a computer science student, did awesome work. They built a virtual reality digital twin of the dam based on the measurements that they get and model, and then they recreated the actual failure and fault, had it both simulated and used the virtual environment for explaining to an audience what happened, why it transpired, where it broke down and couldn't fail. And that was a great success, and it really showed how VR could explain what's happening in complex situations based on integrated real-world math. And also, Hannah went on to a PhD program at Notre Dame University in the same field, so that was another big success.
Stephen always does that. He stole my thunder. I was going to tell the story next. So Hannah got an NSF graduate research fellowship, and she moved to university at Notre Dame. And then, as you all know, Boise State is playing Notre Dame. Hopefully, it is a close game and we win. Go Broncos. Good. Yeah. Anyway, they're all supporting Boise State.
Yes.
Cool. Maybe I'll have Claire. Your students seem to enjoy working in your lab. Is there a story you would love to share?
I think we've had good success working with different clinicians. You know, so I had a master's student who was studying patellar dislocation, so like kneecap dislocation, which happens occasionally in sports-related injuries. And so basically, you know, analyzed a lot of different patient-specific models and gave that information to the surgeon, who then actually adopted it for some of his decision-making, like clinical processes. So that was kind of nice to see that what we do isn't in a silo. It actually is useful information that can be used in practice.
Awesome. And I know many of Anthony's students are awesome. So, Anthony.
We do. We've had a lot of. I've been very privileged to watch students do a lot of really wonderful things. I could talk about. Well, I'll talk about a project that's been ongoing for a number of years. One that actually is done in conjunction with engineering, the College of Engineering, and that's I don't know if my colleague is in the audience. I can't see, the lights are so bright. It's Professor Karen Doty has worked with colleagues in engineering and other students from both GIM and within engineering to work with NASA and to create a series of both virtual, it started as augmented reality solutions for their spacesuits, and then it eventually included virtual reality solutions as well. And that has gone on for, I think, 8 years. And they've gone down to Johnson Space Center to report on that a number of times. I have dozens and dozens of stories. And lately we just did I think a really interesting project. It was Connor Pierce is one of the developers on that who actually worked on clean rooms, a virtual reality training simulation for a clean room, and then actually won an award for that from Serious Games. So yeah,
awesome. Thank you. So Claire brought up partnerships with clinicians and other areas. So it is curious to hear from whoever would like to share what kind of other partnerships, either with industry or government or community groups, that have been most valuable in advancing your work in the digital twin area.
Mm-hmm. Not everyone's going to jump in. I'll jump in. So I partner with the Idaho Department of Transportation. Right. They maintain or are in charge of all of the highway infrastructure, the roadway infrastructure. And there are a lot of hazards in Idaho. And when you have roadways going through mountains, there's often only one way in and one way out. And if there's a rock slide, a mudslide, there's just a mudslide this morning, that causes a disturbance in the system. And so I do a lot of work with them, and I do a lot of work with the Idaho Geological Survey, and work very closely with the head hazard geologists on rockfall type events. So we try and bring that practicality into our research laboratory.
Awesome. Eric, industry has been on your mind.
Yeah, we've got tons of great collaborations with industry and national labs and federal funding agencies across a bunch of our areas of research. So we've done a lot of work with NASA on polymers like these for aerospace applications. We work closely in my school with Idaho National Lab, looking at fundamental problems like how to sinter small particles together to make printed electronics that'll go into nuclear reactors to make sure that those are safe. We do tons of work with the semiconductor industry, so with Micron, with Applied Materials, with Tokyo Electron, with EDM Electronics, Photronics. All of these different companies have really interesting, great fundamental material science puzzles to be solved that working together from a modeling perspective, from an experimental perspective, from a student training perspective, have been essential to the success of our students getting jobs across all of these industries and participating in the economy of Idaho.
Awesome. Anthony, anything from the nonprofit or schools, areas that sometimes we don't maybe pay attention as much?
Yeah, there's a few projects we've done. We've done work in the past with autism research, but I actually, when you mentioned that, you talked about cultural impact. I'll go back. I'll mention a project I said just a few minutes ago, where this is with the Wasma Center and with the Anne Frank Memorial. For those of you who have never visited it, it's just a little ways down here, and honestly, it's a very important part of this city. It's beautiful in terms of what it represents for our values. Unfortunately, it's been attacked a number of times, and that's what kind of brought us into it. From a technical perspective, we were using Reality Kit, and we were basically recreating models of the site to twin it out to understand, because we needed very, very accurate placement on various artifacts that we were trying to show in an augmented reality environment. And what we were doing is, because of course when it's attacked, it's instantly, as quickly as they can, they fix it, and you never know. And yet, those moments in which it's been attacked are also significant. And so I thought what we did is we were using augmented reality, accurate placement of these incidents. We were able to show where things had happened and preserve history, a cultural history for what's going on, so that it doesn't leave the memory of the community. And I thought that was, and in the process too, we had a chance to talk with all the founders and understand all the values that had gone into the building of that particular place. And so I think that's a way to show how this technology reaches into areas that aren't related to industry, but are related to our everyday lives and our history.
Thank you. Thank you for your work. We all heard the thread of interdisciplinarity. Many of you have either led programs or have been leaders or currently leaders of your programs at this university. So this question is around, how are we preparing our students when we need them to be good at engineering as needed, computer science, health, and the arts? How do we encourage these students to kind of work across these disciplines when developing these skills? What are we doing right that they're able to do good interdisciplinary work?
I can speak to a little bit. So one of the things that I think Boise State is doing well at the present time, for its students, for the interdisciplinary nature, is providing them access to resources that give them the opportunity to engage in interdisciplinary work. So the technical resources within the GIM program, the luminary space, by combining some pretty high-end computational equipment, a unique user interface environment with their CS and their GIM-oriented training, gives them an environment in which, so it's important to teach people how to do web development, but students are a lot more motivated around web or interactive development in a unique, large-scale space that demands that they learn new things and create new solutions, as well as deal with things on a scale that so the challenges in the luminary space are much larger in terms of scale of data, interaction with data, how to manage the performance of the system. And by giving them these spaces where they can do that work, they can learn the skills that are needed for them to go out and interact with it. We actually had a great success with INL, where a student learning in the luminary environment went to INL to help them work with some effectively Internet of Things instrumented data feeding into their simulations, and they were able to build and manage and operate their large compute solutions because they had this opportunity to work with these larger, more complex environment where they were studying at Boise State. So that's something. Giving them the environment and the opportunity with these larger scale systems is a real benefit to the students.
So I think something that's special about Boise State University is the current pace of our research growth. And what that means is that for all of the research projects that are happening on campus, we are building the tools, we're building the infrastructure, we're building the experimental apparatuses to do this science. And so that means that the students that are participating in research on campus aren't just following instructions, they're leading discovery with their hands on themselves. And we're doing it across disciplines through vertically integrated projects between different departments. And those conversations that students have when they're trying to figure out, okay, how does this calculation inform the next growth that I'm going to do in this atomic vapor deposition chamber? Or how should I polish this and then look at it under a scanning electron microscope? Figuring out the language between our different labs, between our different disciplines, is where a lot of that learning happens. And I want to maybe touch back on the challenges that we have with teaching this diversity of skills when there's so many new tools coming online and different technologies that we can apply to particular problems. I think that the training across different vocabularies, the adaptability in a really fast-moving environment, those are transferable skills that no matter what discipline you're in are going to help you be effective and be a critical thinker and a problem solver wherever you end up. And I think that's empowering and provides agency for all of our students to do what they want, what they're excited about.
Anthony, do you want to add more? Because especially when I think of GIM, it's arts.
What I was going to say, I think what Boise State both does a good job at and also could do more is this putting practical problems and practical, in environments in which those problems are needing to be solved in front of the students, because that's really the best way to learn, right? Not necessarily in a vacuum of kind of an abstract problem that's kind of set up for you, but rather kind of in the messy world and where you have to really think through what you're doing, and it doesn't work always the first time. And actually that's some of the best lessons is that when it doesn't. I think we do a good job of that. Having said that, we could do more. Yeah, because I really do feel and I would say that's one of the challenges is to find even more and more of those opportunities for the students to engage with these kind of really difficult problems that have that demand that they really pull all of their skills together to answer.
Awesome. Let's get to the next fun segment of the session, which is their questions, answering their questions. So we have some questions here. Let me pick this one. Matthew's asking, how can industry best support and collaborate with a university like Boise State when it comes to emerging tech like reality capture and digital twins, etc.? Any gaps that currently come to mind that we could consider or pursue? It's open to the entire panel. Whoever has a first thought, just jump in.
Okay, I'm going to start the conversation here. So yesterday, 2 days ago, I was at the National Science Foundation at a summit that was about improving industry PhD connections and projects. And the room was kind of talking itself in circles around like what the timing of an industry-sponsored PhD project might look like, or how those funding streams look. And what I came away with was, I think working together, like actually working together to take a problem that you've got at RCN or that you've got at whatever company that you're from, and bringing that to a faculty member to try to noodle on in a particular classroom and teaching that together in a classroom and working on it together is where that magic is going to happen. It's not sufficient to offload to a university all professional development training. And it's not sufficient for universities to offload to industry what it looks like to work in an industrial context. We've got to do it together. And so I think a model of that is bringing projects, people that have graduated, that have been working in a field for years, into a classroom together with students and having some sustained contact together is where I'm eager to push forward a little bit.
And there are some kind of easy ways to do this, so like sponsoring a senior design project, for example, right? So you challenge our students with a real world problem that your company is facing, and you get a little team of students that will spend a year focusing on trying to answer your problem with a lot of interaction along the way and feedback and input from you on what you need. So and that's a really easy way to have access to our students and get them excited about what you do.
Nick, you were telling me earlier you see these companies at your Geotech conferences as well. Is there anything that you would like to see?
I think the hardest thing is when students are doing these really cool things, right? They're usually doing them part of a research laboratory. And so if a student isn't involved in research, how can we get them access to these tools that they need? And so I can imagine almost like a sharing program where a vendor will say, hey, Nick, I know digital twins is important in your field. How about I lend you my laser scanner for a week, and you can go and you can collect all sorts of data, and then you can have your students use that data. Because I can't afford your $200,000 laser scanner. I would love to have one. I'd love to have 10 of them, but the university doesn't have that sort of money. So I think maybe those types of industry kind of sponsorships, sharing programs would be something that's useful.
I would. I just want to jump. So I'm going to take a slightly different tack. It's still related to what you guys are saying. Is with regards to industry. So students and faculty, myself included, often aren't aware of what really takes place within these industrial environments, or how the technology is used, or what the process is. Once that you teach them the best you can, you teach them through the best curriculum that you know. But once they go out and they get a job, there's a lot to learn about what the difference is, what's expected every day, what kind of work, how things proceeds. Actually, so if I were to say one of the things that industry could do to collaborate is a more opportunity for students or faculty to learn the process of what they're doing with the technology so they can see how to best match it to the educational process as well. Because oftentimes it's a lack of, and also we get students who say, why am I learning this? I don't think I'm going to apply it when I get out there. If they have a chance to go out and see or spend some time or serve on a project in which, while the industry doesn't necessarily expect them to magically produce the best work in the world, they're just comfortable letting them learn and sharing that knowledge with the university about what needs to be done in this process. I think that could be something that would be really helpful for the education process and would improve relationships with industry.
Mm-hmm. I think everyone said wonderful things. I think one of the things the industry also has to understand is that when you engage with the university, there's really a series of levels, right? Some of which are, use a senior capstone course or use a course where a professor is interested in taking on a problem. Use it as skunkworks, right? Let them come in, you ask a question, they run at it, they provide you, at the very least, right, they can provide you with the dead ends, right? They can tell you, well, that doesn't work. And you might have spent a lot of money just trying to figure that out. There are other issues that, because we work with industry folks too, and there are IP issues and things like that also have to be addressed. But they're easy to figure out once you just kind of understand the lay of the land. There's also a series of federal granting programs, SBIR, STTR, which are specifically meant to facilitate industry collaboration with universities, and those are all worth exploring. And I think it's kind of that spectrum of first just come at us with we'll call it blue sky problems that you like to have some answer to, but they're not necessarily the biggest foundation of a product or whatever you're trying to do. And then as you see that developing, then that leads to further conversations of how do you refine that into a more complex and profitable relationship with the university.
Awesome. I have a couple of thoughts myself as well. You mentioned IP. Right now, the university recognizes we need to look at other avenues to support our students and the university. And they have, on a journey to figure out how to best do the IP, how can we make it easier for industries to work with us. So that is something we want to be at the cutting edge, that our Vice President of Research and Economic Development's office is really looking into. So if it is a problem, let us know and we will try to solve it. The other aspect that Nick mentioned, you said, it could be lending equipment, time. At the same time, we can also take their money. You could also do scholarships for our students, which is a huge need especially for Idaho students. And those are avenues to also leverage, your company and then, the expertise that you all bring in. That brings me to this comment that somebody made, which hopefully I can. Many of us in this room, they would like to share their knowledge with all of us, and most importantly, our next generation, which are our students. And they'd like to know how RCon 2026, the next one, which is happening in Boise Center, packed with students ready to share their projects, learn, network with these industry leaders. Boise State is ready. We have our students, and Ira Burton did an amazing job, who's the director for School of Computing, to even start this panel. I think this is a first step to then catalyze that. And I think our university is already talking about packing your conference with some of our students a lot next year. So that is happening. So you should be really happy about that. All right. So let me see. I don't know if anybody has thoughts on it, but I'll pick this question. Could you see a future where we have LiDAR-based drone-in-a-box solution that can offer near real-time slope analysis? And how do you work to keep students educated on the most up-to-date technology? Slope.
This is a beautiful question. There are already drone-in-the-box solutions. The state of Alaska has one. I was recently on a team that tried to get some federal funding for the state of Montana for this. And it's a beautiful scenario where we instrument slopes, and if movement is detected, a signal is sent to a drone that lives in a box, right? And the box opens, the drone flies. It knows where to go because it has sensor information of where the slope has moved or failed, and captures information, sends it to a centralized place that someone can make a decision whether action needs to be taken or not. I think this is a perfect place for industry, university, and state agency collaboration. And I think it's the future.
Cool.
Unfortunately, we weren't successful in getting the funding. But we're going to try again, right?
If I may, on the question of how to get connected, I would email department chairs. Their job is to know what their faculty are engaged in, and if you email a department chair with hey, I'm coming from this particular industry or this particular company, and I would love to bring my expertise into the classroom, that department chair should have the context for, this is the right sort of connection for my senior design class or for this microscopy class, or this isn't in my discipline, but I know to send you over to Anthony and get that conversation started.
Yeah, that is one of the questions here. How do other programs and departments in Boise State start utilizing digital twins? And who would you get in contact with accessing this technology within their curriculums? Yeah, you can reach out to any of the department chair. The dean would be happy to connect somebody like Ira, who's a great connector, and you've met some of us here. We are always looking to enhance our curriculum, provide flexibility in our programs. AI is a big deal. We're already talking in our department how to either leverage it and stay ahead, because it is otherwise going to overtake us. Let me see. Maybe I'll ask this. What kind of cross-department projects do you engage with students to blend technologies and methods like bioengineering and XR?
Yeah, well, everything we do is cross department. I would say there's nothing that we do in my lab that's purely mechanical engineering, which is my home department. So I work a ton with kinesiology, with biology, computer science. So we have a gate lab that's about a mile off campus, over at the Yankee Center, and so two or three of our faculty collect data there on human subjects. There's also a baby lab, which is for infants. So it's Boise Applied Biomechanics for infants. So they collect a lot of data on infants, like breathing studies and musculoskeletal studies, and we take all that data in our lab. But again, we do it a lot of the times. We'll want to be in the lab when they're collecting data so we can understand the processes that they used, so we can make sure that we're incorporating that data correctly in the models that we develop. So in my lab, there's absolutely nothing that we could do on our own.
I've got kind of the same answer, but also a good specific advertisement. So we just got $7.5 million from the National Science Foundation to start up the Center for Advancing Workforce Experience in Semiconductors through Outreach and Mentoring Excellence. The center is awesome here at Boise State, and all of the work in the center is cross-disciplinary research like this. So we've got one lab that is doing the machine learning and AI screening of materials. This is Lan Li's lab doing density functional theory, molecular simulations. That information gets passed off to Elton Gronyard's lab, where he grows these new ferroelectric materials that Lan will help discover. And these materials are going to be grown for photonic computing architectures that Karthik Srinivasa's lab in electrical and computer engineering will actually fabricate. We'll use these as the memory elements in spiking neural networks to do in hardware the same computations that we're doing in software on top of GPUs right now, but at 1/100th of the energy footprint. So being able to train ChatGPT-6 with a regular power plant instead of a couple of nuclear power plants. And so all of this work is at the interface between digital twins and actually growing new materials and actually turning those materials into electronic devices and then into fully fledged architectures. And so this center is a great example of one place where 4 different labs are going to be focusing their efforts on a larger, bigger picture problem.
Thank you.
I'd also like to say just a little something about there was the question how to engage in the cross-disciplinary, interdisciplinary projects. So what you're looking at the faculty who engage in cross-discipline. There are others too, but I mean it's generally faculty-led. If you're the university doesn't have a specific cross-disciplinary program, but I do want to. So Eric mentioned reaching out to department chairs, which is great if you can find them, but you may not know which one to reach out to. So I just want to give a shout out to. You can reach out to the university's VP of research. She's she's on the pulse of all the research and projects taking place on the campus. So she's a good contact, and they've set up, and they do have a program within the VP of research office dedicated to collaborative, creative research aimed at trying to foster these types of initiatives as well. So that's one place that's at. And I also want to say there was how to get, also, and all this stuff we do, involves students. So every student at the university who joins on to, and we don't do anything, we're not without the students. So they're fully involved and integrated in all of this activity. So if industry throws us a project, students are going to learn what that industry cares about by working on that project.
Thank you, Stephen. So before we close, I'd like to invite each panelist to share one final thought in about 20-30 seconds. This could be an advice for our students if they're here, a vision for the future, or any key takeaway. We'll start off with you, and then we'll go.
Yeah, construction technology, digital twins, LiDAR, reality capture. It's the way of the future, and we just need to have awareness of it and bring awareness to the school. And if there's something you want to share, please reach out to the department head and come talk to the class. That's the biggest thing I do is exposure.
Steven?
I would just, so for those who asked, how to do collaborations, just reach out. And if you're not sure who to ask them anyways. Okay, that's how you're going to get in touch. Don't feel bad about asking, and try and just do it, and you'll get responses. And that's historically been the most successful route. But ask. Don't be afraid to ask, even if it doesn't look like it might not be the right person.
Spatial computing is the future, and all the things that it involves. I would say the challenge for us here, and also in working with you, is obviously we have a lot of different labs doing things, wonderful things, sharing back and forth between them. We probably also need common resources, things that are not close enough necessarily to what you're doing in research in your lab, but yet do have some kind of a need. It can't fall under your grants because it's maybe not close enough to it, and yet there's a need. And so we have to have spaces where those resources are available for our students, available for us, and in working with you to get the things done that we all need.
Thank you. Nick?
Within my discipline, civil engineering, digital twins is the future, and it is right now. But for you out there, we want to collect more data, higher resolution data, and then we can go forward with all the cool things that society wants with their infrastructure.
If you're working in a kind of a digital twin environment, or you aspire to, you're guaranteed to be doing some sort of interdisciplinary or collaborative research. So, embrace those opportunities, and I think just try and figure out the right people to work with. Don't be afraid to ask questions. You're not going to know everything about your subject, but you find good collaborators to work with you, and together you can build a really powerful team that will be better than its individual parts.
I don't know if this is going to be popular, but I think if you think about the cost of training somebody at your company to get up to speed on everything versus the cost of training a student at a university, I think there's a big return on investment to make the case for higher taxes and using that for public education. I think that is a big return on investment, and it will be less expensive than funding a bunch of one-off projects to get a well-trained, digitally literate, excited workforce.
Awesome. My reflection is, I think I made it. This was my first time doing something like this. When Ira asked, I don't know what I'm getting into, but thank you all for an amazing panel. So we have traveled, as you all saw, from the molecular twins to the built environment, hearing how digital twins play a crucial role, especially at Boise State, how that plays the undercurrent of teaching, research, and connections with industry, and the potential that we hope to see more. Again, we welcome you all to Boise again. Hopefully you had a great time. Thank you. And please help me thank our amazing panelists.